Alright, so we're going to take a look at slope fields. It's not covered in our book very well. It's mentioned in the appendix. It's page A6 in the back of the book. But we'll cover what we need to know here in these notes, and then there's a worksheet to go with this. So differential equation is an equation that has a derivative in it. So we see a dy dx there. So this is a differential equation because it has a derivative. You can read that. This is an important question. It's usually on the AP test. It's worth 4 or 5 points. So we really want to make sure that we're comfortable with differential equations. So 3-step process. Separate, integrate, evaluate. Separate, integrate, evaluate. So the separate, sometimes it's tricky. This is just an introduction, so it's not that bad. So all that means is that the y should be on one side and the x's should be on the other side. So to do that here, there's no y's here. So all we have to do is multiply both sides by dx. So that's going to be dy equals cosine x minus 2x dx. And that's the separate step. We're done with that. The separate step is pretty much going to be multiplying or dividing all the time. Very rarely would you be adding or subtracting. I think I have one example later, but yeah, don't be adding 2x to both sides here or anything like that. That's not good. All right, integrate. So step 1 was to separate. And usually they give a point for separating the variables. So that should be a point we all get. And then step 2 is going to be integrate. So if we integrate dy, we get y. And if we integrate this, we're going to get sine. And if we integrate that, we're going to add 1 to the exponent and divide by the new exponent, and that'll take care of that. And then don't forget the plus c, don't forget the plus c, don't forget the plus c. You're going to lose a lot of points. Forget the points, c. All right, so that's integrate. So we separated, then we integrated. Now we're going to evaluate. We're going to evaluate at the initial condition here. I highlighted it to match that, the initial condition. So that's just an ordered pair. So that's 0, 1 when x equals 0, y equals 1. So if we plug 1 in there, and then we're going to have the sine of 0 minus 0 squared plus c. So the sine of 0 is 0, 0 squared is 0. So c equals 1. So, and then the last step is to write your answer. So our answer here would be y equals the sine of x minus x squared plus 1. Okay. All right, so slope fields should be guaranteed points for us. Basically, it's taken us back to almost our pre-algebra days where we're just evaluating, we're plugging in some numbers for some things. So you may want to pause this and write that t-chart out there. It's got an extra column here for dy dx. So I'm going to show you how to do this on here. So we're going to start at the point -2, -2, which would be down here. And that's what we're looking at right now. Now, if we plug those values in here, that would be -2 plus -2. So that's going to be -4. So what that's telling us is at -2, -2, the slope is -4. So what I'm going to do is I'm going to look at this triangle right here. And I'm going to use this point up here to think about where that slope would be. Okay. Now, we only want to put the slope on in a little spot right here. Okay, but that's just kind of giving you a visual of what's going on. Okay, so that's just the slope at one point, at -2, -2. So you can kind of see I have that little dash there. So now I'm going to go through here and finish these. So that's I'm just adding the x and the y coordinates together. So this is going to be -3, -2, -1, 0, and that kind of on the AP test, when they ask you to do one like this, you just have to put slopes where the dots are. So here we're going to have to do 25 of them. But And I'm not going to do a chart for all of those. We're just going to do it in our head mostly. But so if we move over to -1, -2, then that's going to be -3. And I was just showing how we could keep it going like that if we needed to. So if we go back here at -2, -1, the slope is -3. So I still can use this point up here because that's a slope of -3. And just a little dash on that. Not really that different looking there. As I move up, the slope is -2. When I get to -2, 0, the slope is -2. At -2, 1, which is right here, the slope is -1. So that's going to be right here. And then at -2, 2, the slope is 0. So that's just going to be straight across there like that. Now, we could go over and we could keep going. So then at -1, -2, the slope is -3. So I'm going to use this point up here to give me a -3 slope. Make sure you're on the center of that when you do this. So there you go. Now you can move up here, -1, -1, that's going to be -2. So that's going to be right here. If you move up here, -1 and 0, that's going to be -1. Now, if you think about it, so here at 0, -1, that's also going to be -1. And here at 1, -2, that's also going to be -1. So I went ahead and did all three of those at the same time. And maybe you want to do this one down here, 0, -2, that's going to be -2. So this is pretty tedious. It's pretty basic. Here, -1, 1, that's going to be 0. 0, 0, that's going to be 0. 1, -1, that's going to be 0. 2, -2, that's going to be 0. So we've got that all taken care of there. Now here at -1, 2, that's a little awkward because now that's a slope of +1. -1 plus 2 is +1. So that actually kind of goes up here. Like this. Alright, and 0, 1 will also have a 1 slope. And 1, 0 will also have a 1 slope. And 2, -1 will also have a 1 slope. Okay, now 0, 2 is going to have a slope of 2, 0 plus 2. And 1, 1 will have a slope of 2. And 2, 0 will have a slope of 2. Okay, and 1, 2 will have a slope of 3. And 2, 2 will have a slope of 4. And 2, 1 will have a slope of 3. And that's it. That's all you have to do on a slope field. Usually on a test there won't be 25 on an AP test dots. There'll probably be like 12 or 9. Not as many. Okay. So I could highlight most of these. It kind of just seems pointless to highlight them all. But you can if you want. So we're going to do a slope field again. So the difference here is that it's autonomous, and that means if it's autonomous, only one variable is affecting our outcome. So if we start to do that same chart that we had last time, x and y, and then dy dx, I mean, you should notice right away there's no y in there. So changing y is not going to matter. So we come back over here and we do -2, -2. -2 plus 1 is -1. And then if we go -2 and we change y to -1, it's still -1. that change didn't really matter. Okay, so really all we need to do is check the x values, because the y values don't impact the slopes. So -1 is 0, and 0 is 1, and 1 is 2, and 2 is 3. Okay? So when x is -2, the slope is -1. So I can kind of just go down the column here. All of these in that column are going to be a -1 slope. That's what we're talking about, autonomous. So in a multiple choice question, if you can see all of the vertical slopes are the same, then you know it's autonomous in x. And if all the horizontal slopes are the same, then you know it's autonomous in y. Okay, at x equals -1, it's 0. So just put, I'm doing it a little bit under just so hopefully we can see it a little bit better. Really, it should be right on top there. Seems like that's a little bit harder to see. Okay, and then we move over to 0. When x equals 0, the slope is 1. So these are all going to be 1. So I'm going to pause this. You don't need to watch me. I feel like I'm on a cooking show, and I'm like, hey, here's one I prepared earlier. I've never seen a cooking show. You don't really know what I'm talking about, but I haven't seen that many. But anyway, I did leave these last couple. So the last slope over here, when x is 2, the slope is 3. So I was going here, and then I'm counting down 3 into the left one. So that's there. And then when I come to here, though, I've kind of run out. So now I'm going to switch over to here. So I'm going to go up 1, 2, 3, up to there, and this one, and then come down 1 here. So that's over 1, up 3. All right. So that's the last one there. Okay. Now we want to do a matching question. So on a multiple choice test, this kind of shows both ways it might be actually. This is matching, but on a multiple choice test, what we might see is we might see an equation like this, a differential equation, and 4 graphs, and we might have to match the graph to the equation. Or we might have 1 graph, and we might have 4 equations, and we might have to match the graph to the equation, or the equation to the graph, either way. But so this kind of covers both. Okay? So what I'm going to do is, where do I want to start here? Start with the equation or start with the graph? How about we start, either one. I'm going to start here because this is autonomous, right? Autonomous in x. So we were just talking about that. So these vertical slopes should all be the same. So that, as we look across here pretty quickly, that's going to have to be b. So let's do that. Because vertically, they have the same slopes. Now, as I glance over at number 2 here, that one is autonomous in y. That means all the horizontal slopes have to match up. So that's going to be over here. So that's going to be C. All right. Now, for these other two, I just start looking at points and see what happens. So I've got these two left to choose from. I can look and try to see, is there a difference? So here at -1, 1, I can see the slope is 0. -1, 1, the slope should be 0. So if I come down here and I plug in -1, 1, I don't get 0. Right? So -1, 1 equals 1, which does not equal 0. So that can't be the answer. So now you could just pick them, but let's not do that. So here we can test that same thing though. If x is -1 and y is +1, that does equal 0. So that is A. Okay. So right here, kind of reiterating that, at -1, 1, the slope needs to equal 0. So I was able to do that. Now, obviously, because there's only one left, you could just say, well, that's got to be D. However, that's not a good strategy because we may have made a mistake on something, and then now we'll get more wrong. Whereas if we actually check it, we should be able to find something better there. So now if we go here, it looks like for this one, at -1, 1, it looks like the slope is -1. So if we tried that here, oh, not negative, sorry, +1. Why I did that? Yeah, slope's +1. Well, that's what we had over here. Okay, so that is that. Now, sometimes it's not going to be that fast. Sometimes you're going to have to test. You're going to have to test a couple different ones to figure out what's going on there. Okay, that's just a little bit of a discussion about slope field. You should read through that, especially since our book doesn't have a lot on it. Our book's a little bit older. Slope fields. Okay. Continuing along here. So I don't know. We haven't had much rain here, but in a while. But maybe when you were kids, you remember when there was some heavy rains, monsoon season. You get the water gushing down in the gutters, streets flooding. Can't remember how long ago that was when the road out by the football field, like it was almost a river, that road that goes down there. What is that, Grand Teton? Anyway, so maybe you were out playing in the rain and you would get a branch or a leaf or something, and you would throw it in the water and you would watch it go down the current as it floated down. So that's kind of what is going on here. So this is like the current, and if you drop something in there, you'll see where it's going to go. So let's try that out. So if we were to drop a leaf in here, and this was the current of the water, it might go something like this. Or if we were on the other side, how far I went there, something like, oops, that was not good. I should have. That's not really going with the flow there. It should be out more like that. Now, the key here when you're doing this is bad versus good. Okay, so when we have a little line like that, we have a line like this. So let's say those are our little slope field lines. So that is bad. If you draw your curve through the line like that, better or good is kind of like that. Maybe you hit it in one point, like a point of tangency, but you don't want to be cutting across these little tangent lines. So like you can see there, I glanced that one, maybe I glanced this one, but I'm not cutting across them. Here I kind of drew it on there. I'm not trying to draw, it's not dot to dots. We're not trying to connect those in that way. So I don't even know, this might be better for me to do it this way. So if we move over here a little bit, we might go like that. So I'm almost trying to go in between them more than connecting them. Okay, so there's two. So you can see I'm not really cutting across the tangent lines, the tangent segments there. We can scoot up more here. Something like that. these should be symmetric. I'm not doing the best job there, but all right, and then one more. So, oops, that one's not so great there. All right. So hopefully you get the idea. So what that is, that's 5 different possible answers. It's like a family of functions. Back in your previous classes, when you'd graph the parent function, like x squared, and then you would transform it around, stretch it out, reflect it. So these are possible answers depending on what our initial condition is. We change our initial condition, we'll change what we get there. Okay, so here, hopefully you could pause this now and try to do this one real fast and then come back instead of watching me do the exact same thing again that you just watched me do. But imagine maybe some of you are waiting for the first one. So, okay, so if we're on that side, it would be this, or if we were on this side, it'd be something like that. Okay, and if we move over a little bit, again, if I accidentally go through one of those lines, I just don't want to be crossing them exactly. So I want to be careful not to, and I'm not trying to draw on top of it there, I'm just trying to go with the flow. Okay. I'm almost trying to dodge them, but I'm not doing very well. So there's my third one. And the fourth one. And the last one. Really, that should probably bounce off that. I guess it wouldn't have to, it would depend, because there could be a... Anyway, so that gives you an idea there of the possibilities. Okay. So I've got this one highlighted, but like I said, these could all be highlighted. The tricky thing here is don't confuse this for the matching question, right? These are not differential equations. So don't mistake this for that same question. So the slope field of a certain differential equation is shown. Which of the following could be the specific solution to that differential equation? So if we just pick a point in here and draw our little, like we did up there, something like this. Okay. So if we think about it, which one of these equations matches that graph? So we can put some graphs on here and see which one looks like it might be that. So sine starts at 0, goes like that, back and forth, like this. So starts, no, not really. Cosine starts at 1 and goes down like that, and then it's like sine except shifted over. And so, no, that doesn't look good. X squared, no, over here that doesn't look good. X cubed, I don't know if that's 1/6, that stretches it this way. But regardless, that's the one that's closest to that. All right. And one more. Okay, so again, you all get to pause this maybe and do the whole thing. I'm going to do it, do the slope field, and then I'm going to practice solving a differential equation on that as well. So for the slope field, since it's autonomous, I'm just going to check one x coordinate each because I know the y coordinates don't matter. I'm not even going to write the y coordinates down. So that's going to be -4. Okay. So 0. So I'll put those in real fast. Probably going to pause this because you don't need to be running the video while I'm drawing little line segments on here. And then these are all going to be, well, these are going to be this positive 2, positive 4, negative 2, negative 4. So I'll go over 1 or 2 of them. So this is negative 4. So, and then I'm going to move it down 1. And that's negative 4. Now for this one, I don't have 4 to go by. So I'm just going to have to approximate that. And then 4 here would go up to there. And then down 1 here. Alright, one more. So then it's negative 2. So negative 2 is right there. Move it down and do the rest. Alright, so finish those off, and yours should look pretty much like that. But let's practice our solving a differential equation like we did, I think it was example 1. So remember those 3 steps there. Separate. So try to pause the video and try to do that here. See if you can do that. Oh, I didn't finish this actually. Sorry. I guess I should finish this. Then, so there's the differential equation. Then, probably should finish this before I do something extra. The initial condition 1, negative 1. So 1, negative 1 is right here. So they're telling you, okay, that's your slope field, but we know that you have that starting point. So that is going to look something like this. Okay. So now pause it and do the separate, integrate, evaluate. Okay, so separate, you just multiply both sides by dx. So that's pretty simple. Okay, and then integrate. That's just going to be y, add 1 to the exponent, divide by the new exponent, plus c. And then evaluate, y is negative 1, and x is positive 1. So 1 squared is 1. So c is negative 2. So our equation is y equals x squared minus 2, which seems to match. Okay. This was not part of the question, that's just extra. Okay, so the graphical representation of this is the slope field with a plus c. When we don't know the specific red parabola there, then it's all of those lines. That's the family of possible answers. All right, it's about that time. Have a good day.